Hello. So, in previous lecture, we calculated the work done by gas in case of adiabatic process as well as the change in internal energy, which is same. Now, what we will do, we want to calculate the heat given in the process in case of adiabatic process in terms of temperature and volume, whatever is possible. So, now from first law of thermodynamics, if you see, the dq is du plus dwg. That's your law. Where dq is the heat given to the system, du is the change in internal energy of the system, and the dwg is the work done by gas or work done by the system. So let's from equation 1 and equation 2, let's replace the values for dwg as well as du. So dq will be equals to ncv dt plus nr1 minus gamma dt. If we take the things common, this dq will be equals to n times of cv plus r upon 1 minus gamma dt. Okay. So as you can see, this is your equation, differential equation for heat given in the process in terms of temperature. Okay. So by further integrating this, we can calculate the heat given in the process, and you see this value, these values are all constant. So when once you decide the system, these values are not going to change. So it's sort of a linear function in terms of temperature. Okay. So this is your heat given the system in case of adiabatic process. Now let's calculate the heat capacity in adiabatic process also. So heat capacity in case of adiabatic process. So we have a formula. Heat capacity for any process is equals to dq by dt for that process. Okay. So if you see adiabatic process, it's an adiabatic process. In case of adiabatic process, the Q is going to be 0. So in case of adiabatic process, heat capacity is 0. As we have seen, this dq value in case of adiabatic process, it has to be 0. So if this value is 0, and you can see the Cv and the R is coming here. So if you put the value of Cv here, that's how you calculate. Actually, if you see here, this dq is 0, so in that case, Cv plus R upon 1 minus gamma has to be 0. That's how we calculate the value of gamma. Because the dt cannot be 0. This is adiabatic process, not the isothermal one. So let's put the value of Cv. If I put the value of Cv, it is F by 2 times of R plus R upon 1 minus gamma, and that is 0. And that will make it 1 upon gamma minus 1, I'm taking this on that side, and the R I'm cancelling out, is equals to F by 2. Or we can say the gamma minus 1 is 2 by F. And from here, if you see, the gamma is 1 plus 2 by F. So that value we are getting by putting the value of dq 0 also here. Okay. Thank you.